Assalamualaikum warahmatullahi wabarakatuh. My name is Amal Alisa and my other members Ala Inshira and also Aina Safia are excited to present our project, a ping-pong ball detection and counting system. So let's start with why this system is important. So counting ping-pong balls manually from image takes time and can easily lead to mistakes, especially when the balls are overlapped or have printed text or are affected by uneven lightings. So in applications like inventory management, packaging inspections, or laboratory analysis, an automatic counting system is much faster and more reliable. So that's why we developed a MATLAB image processing system to detect and count ping-pong balls automatically. To address this problem effectively, our project is guided by three specific objectives. Firstly, to develop a MATLAB-based image processing system that automatically detects ping-pong balls from any input image. Secondly, to apply targeted image processing techniques, specifically image restoration, segmentation, morphological processing, and circle detection, to cleanly isolate the balls from their backgrounds. Third, to accurately count and display the total number of detected balls by identifying their circular shapes and marking them directly onto the original image. So now, let's walk through our step-by-step methodology. The workflow begins by loading the input image into MATLAB and converting it to a grayscale format. Next, to tackle noise, we apply Wiener filtering. Then we convert the image into binary format using thresholding. So to clean up the edges, morphological operations are applied to improve object boundaries and remove background artifacts. Finally, the connected components are labeled and the circular half transform is executed to detect the distinct circular shapes of the ball, allowing the system to display the final count. So to show how this looks in the backend, here are two of our primary image processing techniques. So on the left, there's image restoration. So we use RGB to gray to drop the color data, followed by Wiener 2 with a 5x5 neighborhood matrix to remove noise while preserving critical edge details. So on the right is image segmentation. We calculate an optimal global threshold using gray trash and convert the fitted image to binary with binarized. Finally, complement is applied to invert the binary image so that our target ping-pong balls are represented as clean white regions against a black background, vastly simplifying the detection phase. So that's all from me.
My name is Ayuna Safia binti Shukri. Today I will explain the program code. This part is used to improve the binary image before detecting the ping-pong balls. First, the system fills any small holes inside the ball so each object becomes complete. Then it removes small unwanted objects that are considered as noise. Finally, it smooths the shape of the object so the ping-pong balls become clearer and easier to detect. These are the first three steps in our image processing. First is image acquisition, where the system reads the original image into MATLAB. Next is image restoration, where the image is changed into grayscale and the noise is reduced to make the image clear. After that is image segmentation, where the system separates the ping-pong balls from the background by converting the image into a black and white. This makes the object easier to identify. Next is morphological processing. This step removes the remaining noise, improve the shape of the ping-pong balls so they become more complete. Lastly is circle detection and counting. The system detects every circular object and automatically counts the total number of ping-pong balls in the image. This is the original image before any processing is applied. It shows all the ping-pong balls that will be detected by our system. This is the image after the processing stage. As you can see, the background has been separated and the ping-pong balls become much clearer. This helps the systems detect and count the balls more accurately.
I'm Shira and I want to continue this presentation. As you can see in this output, thresholding converts the original grayscale image into a binary image. This is a crucial pre-processing step where we separate the ping-pong balls from the background. By applying an appropriate threshold value, we create a binary representation where the balls appear as the white regions against a black background, making them ready for further analysis. Next, we apply morphological processing to our binary image. As shown here, this step removes noise and eliminates unwanted regions that could interfere with accurate detection. The morphological operations clean up the object boundaries, producing smoother and more defined shapes. This ensures that when we proceed to the detection phase, we have cleaner, more accurate representations of our ping pong balls. This step significantly improves the reliability of our counting system. This slide shows our final detection results. The system successfully detected a total of 12 ping pong balls. You can see that each ball is clearly marked with a green circle, which we achieved using MATLAB's I'm-Fine circle function. This function implements the circular halt transform to detect circular objects in the image. The green circles indicate the detected objects, and each ball is individually labeled for clear identification. The total count of 12 is displayed automatically at the top. The system demonstrates high accuracy in identifying and counting each ping pong ball in the input image. In conclusion, we successfully developed a ping pong ball detection and counting system using MATLAB image processing techniques. The system performs several key operations, reading an input image, preprocessing it through grayscale conversion, and Wiener filtering, segmenting objects using threshold-based segmentation, refining the results with morphological processing and connected component analysis, and finally detecting circular objects using I'm-Fine circles. This project demonstrated that digital image processing is highly effective for solving object detection and counting problems. Our system reduces manual counting effort, provides fast results with a good accuracy, and shows how combining multiple techniques yields better performance than using a single method alone. We reference MATLAB's documentation, particularly the I'm-Fine circles function and the image processing toolbox. Thank you for your attention. I'd now like to move to a live MATLAB demo to show you the system in action. We will now demonstrate our ping pong ball detection and counting system running in MATLAB. Let me show you what happens when we run the complete program. The system produces 5 key outputs. Let me show you each one. This is our input image. It contains ping pong balls that we want to detect and count. A human would count 12 balls here. The system first applies noise removal. You can see the image become cleaner and smoother, which helps with detection. Next, it converts the image to black and white. The ping pong balls are separated from the background. This makes them easier to detect. The system then cleans up the binary image. Notice how the ball shapes become more defined and any small specks of noise are removed. And finally, the detection result. Each ping pong ball is marked with a green circle and labeled with a number. The count is displayed at the top. The system also displays the final count in the command window, and it shows a confirmation message box with the result. Total ping pong balls detected as 12. And that's our complete demonstration. The system successfully detected and counted all 12 ping pong balls automatically. Thank you for watching.